She's just challenging. Or you're just challenging.
Geometry, Trooper Tide Tuesday. Happy Trooper Tide Tuesday, guys. On the 25th. 25th of February. SFBA students will be able to. Celeste, don't throw things.
My bad.
Identify and use properties of similar triangles. Celeste, no cap.
Literally. No, I don't have a hat.
Yeah, I know. You didn't take it.
Well, I tucked it.
You yoked it.
That was so funny though. She I even went like that and it stayed on there. She used it.
Technically, if we do a dictionary, we can make up any past tense from the one.
Yeah.
Yes.
That means someone has to have proper past tense.
Cool.
Alright. Hey. Now guys, this is our last section, meaning what are we doing next class? Reviewing. What comes after that? Yes. So take your test next Monday, okay? I know we love Mondays, so maybe even better, okay? So.
I won't be here.
I will be sick.
Okay.
Wait, what?
So.
I legitimately will be.
Triangle proportionality theorem and using proportional relationships. So we're going to learn about this triangle proportionality theorem. Okay, learn about triangles and how they're proportional. If a line, what? February 25th.
No, it's not.
Okay.
Wait.
No, you're Gracie. Okay. If a line parallel to a side. If a line parallel to a side of a triangle. Nolan Brady.
Wait,
Oh,
can I just say
Grace,
something
no,
really quick?
sorry, no. If a line parallel to the side of the triangle intersects the other two sides, then it divides those sides proportionally. What that means is line EF here, it is parallel to a side of the triangle BC. Line EF, the one that's parallel to the side, also intersects the other two sides. So that's our starting point, that's our if. If we have the setup, which we do, then it divides these sides proportionally. So it's saying A to E, the top part of it, over E to B, the bottom part of that side, is going to be equal to A to F, the top part of the other side, over F to C, the bottom part of the other side. So it's saying that if they're parallel, if those lines are parallel, when the segment and the side are parallel, okay, I don't know what that face is, okay, and it intersects these other two sides, then it divides them proportionally. Like, can we set a proportion a different way?
Like, yeah, like, can line EF go through line EA or BC and not intersect with AC and parallel to AC?
Yeah, it could be like down here. It'd be parallel,
Like,
not intersect. Is that what you're asking?
Like, can it go like this?
If it's parallel to that side, then.
Like, it doesn't matter.
As long as it's parallel to one side and it intersects the other two, this is true. Yeah. So let's find the length of this segment here using the triangle proportionality theorem. Heads up, this 9 real quick, everybody changes 9 to an 8. Everybody changes 9 to an 8.
That means it wasn't congruent.
It means it wasn't going to work out nicely at all.
Yep.
And now I made it work out for it, a whole number instead of like a messy fraction decimal. So here we're going to find the length of the measure of CY. So we're going to find the measure of CY. For our triangle proportionality theorem, we have a line intersecting the other two sides that's parallel to the third side. So that's set up for the triangle proportionality theorem. So we know is that it divides the two sides, intersects proportionally. So a proportion that we could do here is 8 over 4. 8 over 4 is equal to 10 over this missing part, which we could call anything. Right now, I'm going to get creative. I'm going to call it a smiley face. Okay? Grace.
Don't we already know that CY is going to be 4 since B, C, and XY are parallel?
Okay. Well, let's find out. We'll find out if it ends up being 4 or not.
It's not like it has to happen. Because parallel lines, if it's like, if one side is bigger than the other, then they're not parallel.
Okay. So that would be if these were also parallel. If those were also parallel, then that would be
smaller than that side. They're gonna intersect at some point.
Yeah. So these two lines intersect, like BA and CA, but BC and XY never will. So these have lines cutting out in different ways.
What if that X instead of a smiley face?
Sure.
I thought it was inconvenient.
Okay.
Why did they draw a smiley face right
Maybe you're just happy about math.
there?
That's
Never
so
been
hard to
that-
believe.
Never been
Okay.
that.
So then we can look to cross multiply and simplify here just like we have been doing. So we're continuing to set up ratios, and then from there we can practice ratios. So why can we simplify 8 over 4?
Yes.
To what?
2, 4, 2.
Not 4 over 2, but 2 over 1. 2 over 1. 4 goes into both, we can simplify to 2 over 1. Now we can cross multiply. Okay? 2 times smiley face would be 2 smiley face. What's 1 times 10? 10. How do we get our smiley face by itself? Divided by 2. So our smiley face, aka CY, equals what? 5. Okay. So this ends up being this measure ends up being 5 here.
I do not understand how
Okay. It's because of the angle that these two lines are at.
Every time we get can we do that?
Something.
Oh my gosh, yes. Did you tell
So,
me part of it?
A good way to look at this, guys, is as this is divided proportionally on these two sides. 4 to 8. How do you go from 4 to 8?
5 by 2.
How do you go from 4 to 8?
Add 4.
Double it.
Time. Multiply it by 4.
Multiply by 2. How do you go from 5 to 10? Time multiply by 2. So same concept here. Okay. So 4 to 8, double it. 5 to 10, double it. Okay. Just like early on our board, 2 over 6, 2.5 over 7.5, 3.3 repeating over 10, all 0.3 repeating. Same concept here. These are both getting double in this case. It won't always be double, but they're always going to be proportional when we have the setup here of the parallel lines that intersect the third side. If I asked you guys to try and set up, to find the measure of PN, if I asked you guys to find the measure of segment PN here, how are you guys going to do that?
PN or PN?
PN, here to here. It's a decimal. It's a decimal. I encourage setting up a proportion. Setting up a proportion best we can. I have to great with them. I'll be right back.
What in the world? Why are they gonna
So this kind of here to here, and go here to here. On this fraction, get the set on the top, set on the bottom, which is fine. Here, then you flip it around. Here it is on the top.
Oh, and then you see the opposite.
Yeah.
Oh, okay.
You want to check?
Yep.
Hold on.
I would say you're good out of this
What is
one, right?
5 divided by 5? Right there.
Right in it.
So, what was your horse's?
Tyler,
I don't know how it works.
I'm so confused.
see it at the bottom of the top.
Okay.
So we'll get to here.
I can write, I can check.
No.
So,
You gotta pay me for it.
it's hard! It's hard! Scaling for Mexican. Oh, check my Bro. Oh, check.
Hold on.
I thought you were wearing braided hair.
Okay, so
This is what I said.
so it's
I didn't want to do this.
Well, you could have but on the second part, this is
Showing it hours?
Oh my god.
Yeah, yeah, Now I
Okay, I need help. Hi.
Taylor, do it. Do it.
I woke up at 5
You
a.m.
should. Kids, hey, I swear. You're not.
Lost.
What do you want?
Okay, so.
There's your blue.
So it's big side of.
Well, I wouldn't want you to hide it.
5/2.
Yeah, I know.
There's things,
X over
shelves,
here.
ladder.
Well,
I enjoy it.
And then you cross multiply, so 2 times X and then 5.
God
What are
damn.
you talking about?
So mean to me.
These two things are here.
It's 2X equals 15.
Well, like,
So, say not, that would be $2, so I'll put it on your tab. I'm coming. No. I don't think so.
Okay.
I'm sorry for you, X.
What?
Even
They look like. That's what I'm saying. I don't see it either. July.
It's on the other page.
Clearly my business says.
Taylor,
there's
You
a-
want me
there's
to
a-
do this one?
Yes.
Yeah,
No.
and
Yes.
you could have one of them help you set up too.
We're talking about how much you would like for 9 months. 15
months.
months in July.
Who wants to set this one up?
I'll do it.
Hold on.
Now.
No.
Literally.
Hashtag tall people outside.
Anybody got any questions about that?
Why'd you do it like that?
I'm a baller with a shot collar.
Are you saying that you think you should have been 2 over 5?
Yeah.
Or you ever actually do it?
Oh, okay.
I did 5/2.
Because I was thinking of something.
There's multiple ways to do that.
Guess what?
Bigger.
I can go
They have to
bigger
like
too.
that. And they're
You get a blower right in here.
Yeah.
I'm getting on.
How do I make sure that I
No,
don't-
Lynn, you always,
Are you guys
you always
listening?
just quote things wrong.
Are you guys
Oh.
listening?
Yes, ma'am.
Yes, Miss
You
Haslow,
said
we're
I'm a
listening.
baller with a soft collar.
I know that's not how it goes.
Let me know when you're ready.
Ready?
Do you know how I figure out if I did it right?
How?
Because I put the
I know.
7.5 back into the X's
Julian.
and then divide down, and if I tell me you should come up with 0.4 on both of them. And you know that it's right because they match.
And now, was there anything special with getting 0.4, or was it just because they matched?
Well, because it wasn't about 0.4, it was because they both had to match.
So when you go back and check your work, guys, hey,
Listen,
Mrs. Haswell is giving you a great tool here, guys. When you go back and check your work, and like she's saying, plugging whatever you found in, so in this case 7.5, back in for your X, your variable, your star, your schematic, whatever you use. When you plug it back in, and you divide your fractions, you should get the same thing for both fractions if you got it right. Mrs. Haswell got 0.4 with the way hers was set up. Yours might not be 0.4, but yours might still be right. So as long as they match, that's what matters.
and I still, after 6 years, make sure that I divide them out when I'm done because I am notorious for putting them in the wrong spot. Which is what Grace was doing, trying to put things on the top and other things on the bottom and not matching.
Thank you, Ms. Haswell. I'm gonna actually sit up here and talk about real quick about the orders that we can do. Because we can do a lot of different orders. So did somebody else do a different order than what we had here? Okay, Braden, what did you do?
I did 5/2 equals X over 3.
Okay, 5/2 equals X over 3. I'll talk about why this one works. Okay, I'll talk about why this one works. Okay, thank you. So 5 over 2, we're still dealing with the same side right now. So vertically, it lines up. Vertically, it lines up. They're both dealing with the same side. They're both on the right of these triangles. X over 3, vertically, it still lines up. We're dealing with the same sides of the triangle. Horizontally, 5 and x, they line up because they're corresponding. They're both the bottom parts of these triangles. Horizontally on the bottom, it lines up. 2 over 3, they're both the top parts of these triangles. So if you can line it up vertically on both sides and horizontally on both sides, you're good to go. So for example, 2 over 3 works because vertically, it still lines up because 2 and 3 still go together. They're still the top parts of the triangle. Vertically, 5 over x lines up because they're still the same parts of the triangle. Horizontally, they line up. 2 and 5, they're both on the right. 3 and x line up horizontally because they're both on the left. So as long as they line up, we can set it up however we want. So an example of something that does not work, and why it doesn't work, would be 5 over 2 is equal to 3 over x. And the reason why this one does not work is horizontally or vertically, 5 and 2, they're both on the right, so that lines up. And vertically, 3 and x, they're on the same side, so that lines up. Once we start going horizontally, do 5 and 3 line up?
Kind of.
Not really at all. 5 is the bottom part, 3 is the top part, and they're all on the same side of the triangle. So they don't line up at all. So horizontally, it falls apart. Same thing with 2 and x. They don't go together at all. Okay? One's the bottom, one's the top, one's on the right, one's on. They don't have anything in common. So it falls apart horizontally, which is why this one would not work, or a variation of that one would not work. So there's a few that will work, a few that won't work, and it's all about whether we can actually line them up. So if you look horizontally, if you look horizontally or you look vertically, as long as they can still go together, as long as they still line up, you set up a good proportion. Okay. Questions on that? Okay. Did that help clarify any of that on why some of us were getting different ones or how we might set these up? Okay. So there's more than one way to do it. There's more than one way to skin a cat. Okay.
What?
It's a saying.
I've heard that saying
You
before.
anyway,
but
say that is like.
I've heard it, but it's tough to remember.
Hey,
Well, I mean, cats aren't good anyway, so.
back when I lived at my house, my old house, my dad, we used to shoot them.
Yeah, you can start from the.
Because listen, we raised pheasants. We used to raise pheasants and they would eat all the eggs. So we used to actually have contests to see who gets the most cats in the house.
For one.
It's true.
My dad did a little one.
It's true.
No wonder he actually.
Good idea.
Anyway,
I'm not gonna be.
hey, so, yeah, hey, Grace, thank you for talking yourself. Okay,
Ours kill pheasants.
thanks. Okay, hey, let's focus back up here. Hey, let's go back to the board, guys, okay? Right, I'll say it like Jillian says that about me. Okay, let's go back to the board, guys. Okay, not too far off how I actually sound. So anyway, converse of the triangle proportionality theorem. So we have the normal triangle proportionality theorem. We said, hey, if the lines were parallel, we can set up a proportion. Converse is just going the other direction around, saying, hey, if the proportion is true, the lines have to be parallel. If the proportion is true, it has to be parallel. So if a line divides two sides of a triangle proportionally, and this is true, then they have to be parallel, which is going the opposite way. So here, verifying that these lines are parallel, verifying that segment MN is parallel to KL, if we set up a proportion here, and it works, they're the same, then they're parallel. If it's not, they're not. Can somebody help me set up a proportion here using that knowledge and that kind of proportion setting up we just did on the previous slide?
21 over 15.
Okay.
Divided by 42 over
91 over 15 equals 42 over 30. And this would be a good proportion to set up, very good, Grace, because vertically they line up. You're dealing with the left of both sides. Vertically they line up over here, you're dealing with the right of both sides. Horizontally they line up. 21 and 42 are both dealing with the top. And the bottom 15 and 30, they line up horizontally because they're both dealing with the bottom sides there. Okay? So they all line up. And so now this would be an example of a proportion. It doesn't have to be the only one, it's an example. And so if you find out that these are equal, then these lines are parallel. If they're not equal, they're not parallel. 21 over 15, we can work to simplify that, or we can push it into a calculator and have it do our work. Colton, what goes into both 21 and 15? Okay, 3 does go into it, okay? You don't even need the word frickin', but it is true, okay? So, how many times does it go into 21? 7. How many times does it go into 15?
5.
Okay, so 7 over 5. What's 42 over 30? What goes into both of those? 6. How many times does 6 go into 42? How many times does it go into 30? I'm sure they have 5. Okay,
10.
so are these the same?
Yes.
Yeah.
So are these parallel? Yes. So our answer is like, you can just be like, yes.
Yes.
Segment MN is parallel to KL. Okay, and that's our proof. We got them to be equal.
Why didn't you put KL as a segment?
Oh my goodness, I forgot.
Oh, extra point. You.
Oh.
Wait, does that count as an extra point?
Wait, so hold on.
Oh, I'm sorry.
Holding on.
Why'd you put them all down to 7 and 5 and 5?
Because.
Need some water?
I can say it.
Wash all that salt off.
Because 21 and 15.
I can tell.
divided by
You're
30
pretty
is
pretty used to it being there.
42 over 30 can be simplified by 6.
A student states that segment UV must be parallel to ST. Do we agree? Why or why not?
Or
So they say, hey, these have to parallel. Do we know any lengths?
No.
We proved some things parallel a moment ago by setting up a proportion, but we do lengths. Do we know lengths here?
No.
Okay, let's start maybe putting some variables on some lengths. What could we call UR?
X.
Cool.
Y.
Where? Where are you going to put Y at? Maybe that's another question.
RV.
RV, cool.
VT. B.
Okay, what can I call VT?
Z.
Why?
Wait, Braden, what did you tell me I can call it?
Y.
Why can I call it Y, Braden?
Because they're congruent.
They're congruent, they're the same.
Thank you, Brayden.
Same with SU.
So can I call USX? Yeah, it definitely can. Or you don't say SU, same thing.
What about ST?
Okay? Oh, we don't know it.
That's what we're figuring
Exactly.
out.
We don't need to. Now, even though I don't have numbers, can I set up a proportion to see if these two lines are parallel?
Yeah.
Yeah, just like I did on letter A, excuse me, not number, on letter A. It's like Grace helped us set up a proportion here. We can do in here. Can do what? Not for a proportion. For a proportion, we set up two fractions. So what could the proportion look like, Braden?
X over Y equals X over Y.
Okay, you could do X over Y equals X over Y. That would work. Okay, you could say X and Y vertically. Okay, yeah, they're the same. X and Y vertically, they're the same. And then horizontally, X and X on top, Y and Y on top. That could work. Okay, you could also do X over X, Y over Y, Y over X, Y over X. Okay. Now, are these? Can we tell these are the same thing without even simplifying?
Yes.
Yeah, so we don't have to simplify. So are these in fact parallel? Yeah, so do we agree with the student? Yeah, we agree with the student. And our explanation, okay, can just be as simple as the fact that X over Y is equal to X over Y. That can be our explanation there.
But I need unknown type.
Another explanation could just be saying the sides are divided proportionally, something like that if you really wanted to. I don't have to though. I know Jillian was really hoping for at least 3 or 4 more explanations, but sorry, I only got 2.
You know what? I think for Thursday for like a fun like thing, we should do like a throwback.
Throwback Thursday?
Like so you should wear like one day you could wear like hippie glasses.
Interesting.
Just like a little thing.
Yeah, it's like a small, subtle thing.
Yeah.
All the workshop.
I think you should do everything like a thing for every day.
See, that's the tough part. Is okay. So Hannah will be happy this came up. So Hannah is actually interested in trying to become included in this a little bit because she knows I do all my gimmicks. Okay. And so and believe it or not, she still loves me even though I do it. No, but anyway, and so like one of them she wants to hop in on, and she wants to start a marriage Monday to where she gets to pick my outfit on Mondays. Okay.
Yeah.
Now,
that's
and
a
I
good
was like,
idea.
that's a what?
That's a good idea.
Good idea. She likes it. And she was actually last week, and she's like, hey, you should ask your students sometime if you get the chance to about Marriage Monday. So it came up pretty naturally here, I'd say. So what are your guys' thoughts?
Yes.
Yes.
You guys are all for it? Okay. The
Well,
outfits,
you have to do something on Thursday
okay,
too.
the outfits wouldn't look as good, I'll be honest. Okay, but I'm better at color coordinating. But anyway, but no. So the thing is like I don't want something every day of every week.
Why?
So because then like okay, low key, like I can only wear certain shirts on Tuesdays because I only have certain shirts that go with my trooper ties. So like I'm already pretty restricted on my wardrobe. On Wednesdays I have to wear pink, and like I've done this myself. Don't get me wrong. And like on Wednesdays I have to wear pink, so I'm pretty restricted on what I can
So
wear
you
on
need like a
Wednesdays.
free day.
And so like it's kind of nice to be like,
Yeah,
oh, like Monday
Mondays-
and Thursdays are like free days. I can wear whatever I want, you know. And then Fridays, Smells Friday, and I wear like my jeans and like a blue devil shirt. And so like Monday and Thursday are kind of like my free days. So right now, what we're workshopping right now, and what Ann and I have kind of soft agreed on, I would say, is doing a Marriage Monday like one Monday a month, like the first Monday a month, Marriage Monday. And so she picks out my outfit.
Are you picking out
on the
her
first
outfit?
one. Well, I mean, at work, like she has to wear like scrubs and scrub top.
Oh, that's it.
Yeah, I mean,
So it's like you don't really have to. Wait, what does she do?
nurse, pediatric nurse.
Aww.
Yeah, she's finishing up school right now, and she started her job this summer. But one Thursday a month.
You should do
Maybe.
throwback, I
Maybe.
swear. And like,
You should swap outfits for a day.
Like Anna and me. I already swapped outfits with Mrs. Popham last year.
That's
that was so funny.
Yeah, Emily, you weren't here. Yeah, I rocked the dress. Seriously, yeah. She wore my shirt and tie and slacks, and like I
the
wore a
dress
dress.
like had little like cups in it. You know what I'm talking about?
No,
you had to wear a bra. No, like little like the
No.
things were like little like like that, right?
No,
Yes, it was.
No,
I
I-
know.
I was
That's not
wearing it.
imagining that. You were.
I'm not gonna lie. It was really comfy. To be honest. Like it was very
She
roomy
is
and
like-
breezy.
Yeah.
Oh my god.
Yeah. But I'm not gonna lie, it was pretty comfortable. It was more comfortable than I expected it to be. So
That's fun.
yeah. And it had pockets. I was so happy, okay, because like it's a real thing. The girls in here know, okay? When like dresses don't have pockets, my goodness, like women's pockets in clothes are typically terrible. They barely even pockets if they're pockets at all.
We don't
Okay?
have back pockets.
And it's stupid. Okay? And so like as like we were about to go change and swap clothes, it hit me, I'm like, I'm not gonna have pockets the rest of the day. And I was like pretty upset about it. And then like we go into like, we go and we change, I'm in the locker room changing, and like I put on the dress and I'm like, there's pockets! And so like, I went up and thanked her like after I'm like, thank you so much for picking one pocket. She's like, I got you. So and she got me and like, she had a necklace for me to wear and stuff too. Anyway. So
I actually know the reason why girls' pockets are so small.
Why?
So clothing companies can sell girls' handbags.
I can see it. That makes sense.
Big brain.
Big brain.
That's dumb because I don't even hear
Plot twist. Hey,
These are so ugly.
How do you think
Okay.
Gucci makes money?
finding an unknown height. We have this thing called indirect measurement. That's really bad. Let me redo that. Indirect
Sorry.
Bruh.
measurement. Oh man.
Bruh.
Yeah, that goes back to freshman year for you guys, doesn't it?
Bruh.
She loves that. Yeah. Totally. Okay. Indirect measurement. Yeah, I know. I'm well aware.
Oh, you were in here before?
Me?
Missouri.
What are you talking about?
We have Urby for half a year last year.
Her teaches like everything.
Who's Urfi?
Okay.
Oh, there's an Urfi.
Okay. Indirect measurement involves using the properties of similar triangles, which is what we've been talking about, to measure heights or distances that are too great to be measured directly.
Oh,
So really big heights or distances.
Does it
Okay?
make you feel bigger when you're in the chair?
Yes.
Like you have more authority?
No. This is fun.
How's that?
You're weird.
Yes.
I feel like even when you're
I've
like
never
an
denied that a
8-year-old
day in
man,
my life.
you're still gonna do that.
Probably. Okay.
Like you're not like a nerd, but like I mean
I mean, I am
everybody's weird.
He reminds
Everybody
me
does
of Jacob Frazier.
Yeah.
No.
Sure.
Oh my god.
He does remind me of Jacob
Oh.
Frazier, am I
Ooh.
right?
No.
Ew,
Yes.
no, don't say that.
What do you
That's
mean?
really Jacob
No.
though to say it that way too.
Sorry.
No, they're like in the
I would
same.
take him.
They're into like the same type of thing. No.
No.
Like
What's
me and
Jacob
he's
No,
like
no, Grace.
Yes.
No.
No, me and Jacob are friends. I'm friends.
He's like
Frazier.
He's like
Jacob Frazier mixed
And
with
he's off.
Wiseman.
Yeah.
What?
Like if Wiseman and Jacob were like
No, I'm saying be careful where you're
I was
going.
like I know like if you put like Caleb Wiseman's personality and Jacob Frazier's personality together.
Oh, I
They
thought
don't-
you meant like the gym teacher.
No.
I was like, he
No,
is
it's
messing like the
different.
gym teacher. You're not like Jacob Frazier.
Yeah, he's
How
like
do
nerdy
you
like
get that?
No, I
Like,
totally
they're-
see it.
they're
into the same things. I talk
Like,
to
I
Jacob
feel
all
like
the time.
you call me nerd? Did you say he's nerdy?
I am.
Yeah, he is nerdy.
He is.
You gotta get to know people
Star Wars.
before you
Marvel,
judge them.
Marvel.
That's not nerdy. That's
Yeah,
just
it is.
You just gotta get to know people.
Jacob's actually pretty
Nerdy.
nerdy.
Jacob like plays a ukulele, you know, like
Oh,
you're the
yeah.
type of person that
Jacob throws snowballs at my truck.
No, I know,
Who is
but
this
you're
kid?
the it's like
He doesn't have my
Yeah.
He plays
Mr.
it.
Costa, I guess you guys, if you said he's like the mature version. Yeah, maybe that makes me think a little harder. But I do not.
oh of a toddler.
Yeah.
Oh, extra credit point gone.
Okay. In order to find the height of a palm tree, my mom loves palm trees, okay? You measure the tree's shadow, and at the same time of day, you measure the shadow cast by a meter stick that you hold at a right angle to the ground. Colton, what angle is the meter stick to the ground?
What?
What angle is the meter stick to the ground?
I don't know. They accidentally signed it.
Nope. It is at a 90-degree angle, right angle. That's what it said there. That's what I read as you were talking to Grace. Oh, that's why I said meter stick. And actually, by the way, the palm tree's at a right angle to the ground too.
Yeah, but I couldn't see it.
Okay, it's also on your paper, but you would have known either of those.
Yeah.
Attention. That's what I'm getting at. Okay. So, but I mean, I would let the palm tree get though. So we takes one to know one. Okay. Measure the tree shadow.
Ooh.
And we're told that the tree shadow is 7.2 meters. So this is our tree shadow. Okay. And for anyone who's wondering, I did write my S like a normal person, not like Celeste. Okay. And at the same time of day, you measure the shadow of the meter stick. Now we're told the palm tree shadow is 7.2 meters. The meter stick shadow is 1.6 meters long. We know the meter stick is 1 meter tall because it's a meter stick. We don't know the palm tree, so that could be our X. We were finding the height of the tree. Now we're told we're doing this at the same time of day with some shadows. We're told we're doing this at the same time of day with some shadows. So we have our sun here. Okay, I'm going to draw a sun here. Don't worry, I'm getting there. Let me try.
Let him do his
Because some
thing.
people forget the sticks.
Well,
It
some
kind
people
of
are
feels
wrong.
like a blob.
Well, that's what the sun is. The sun doesn't have sticks.
That could have been way worse.
That's actually really good.
Thank you. Thank you.
Horrible.
It should go in the art display.
Okay,
I used to do
so,
art display.
we have the sun, and the sun casts a shadow.
To drop out right
The sun casts a shadow onto the tree and on the meter stick. And we're doing it at the same time of day, because what's going to happen is if at the same time of day, the angle coming from the sun to the tree and the angle coming to the meter stick from the sun are going to be the same angle there.
Did you just draw that?
Okay, yes. Pretty decent, right? Take less of us read down that for us forget.
I sometimes think that people just don't know how to read.
What?
I'm sorry. I'm very upset right now. You can go.
Thank you.
That was
So
random.
these angles end up being congruent because the angle the sun hits the tree and the meter stick are the same because it's the same time of day. If they're at different times of day, the angle would be different because where the sun's at in the sky. Like at noon, where's the sun at?
Right above them.
Like right above us, okay? Whereas like in the morning or afternoon, it's like angled, right? Okay, so the angle it hits an object for the shadow is going to change throughout the day, okay?
Wait,
So-
did you draw that?
What's your costume?
Yes.
Big brain cut. Noon is at the top of the clock.
Yes.
And the sun.
Yes. Yes.
Oh, because those little pendulum things.
Yeah.
are like,
Sundial.
Yeah, sundial.
Yeah. So, let me know a right angle here. We had to hold the meter stick at a right angle because a palm tree will naturally be at a right angle to the ground. So now we have the triangles are similar from angle similarity. triangles are similar by angle similarity. So we can set up a proportion here to find our x. Can somebody help me set up a proportion here to find our x? Okay, Gracie.
Is it bigger or smaller?
Sure. We're gonna do smaller, big, small.
Okay,
Just one that we don't actually care.
1 over 1.6.
Okay.
And then x over 7.2.
That would work. 1 over 1.6 and x over 7.2. The reason why it works is vertically. 1 over 1.6, we're dealing with the same triangle. Vertically, x over 7.2 dealing with the same triangle. Horizontally, 1 and x, we're dealing with the height of the meter stick and the height of the palm tree. They're both heights. Horizontally, 1.6 and 7.2 are both shadows. So it lines up horizontally and vertically. Good kick there, okay? So now if we solve this proportion, we can get how tall the tree is. Question on the setup. Okay, this is where calculators come in handy, help us solve these proportions, but we cross multiply. What's 7.2 times 1? 7.2. What's 1.6 times x? 1.6x. How do we get x by itself? Divide by 1.6.
They might have yelled at me.
So x equals whatever 7.2 divided by 1.6 is. Okay, what? 4.5. So that means the palm tree is how tall? 4.5 meters tall. Very good. We're talking about 4.5 gorillas tall. Another about 4.5 peanut butter sandwiches tall. We're talking about 4.5 meters.
That gets it. Each 45.
4.5. 4.5. I also know that you just said peanut butter. I don't like peanut butter and jelly. I don't like jelly. Okay.
Peanut butter and Nutella.
Okay.
me
Yes.
off.
Game changer. Questions on this one?
I just got flipped off.
By
who?
Grace.
Okay.
Twice.
Sid. Sid here is 72 inches tall. No, Sid. It's 72 inches tall.
No big deal.
Yeah, Sid the sloth. Okay. Hannah can do that really well, creepy well. Sid is 72 inches tall. To measure a flagpole, Sid stands near that flag. Sid's friend Miranda measures the length of Sid's shadow and the flagpole shadow. Okay. Find the height of the flagpole. Once again, we have a sun. What's up?
You can have it. You can eat it. Okay.
What about me, bro?
You can not. No! Why would you do that? We'll see.
Yeah, that's even better something than last time.
We'll see about this.
No, I like the original.
No, me and you, the other one was like
You need to try and hit on that.
Yeah, I tried to make this more circular.
Yeah, I like this more circular.
Yeah, this one looks good.
We'll try. We'll see.
Alright. So, we have the sun. We have the height of the flagpole. We know the height of Sid. Sid over here has really long legs. And Sid's 72 inches tall.
Woo!
This
That's
is the
6
shadow.
feet.
That's really tall.
It's 6 feet tall.
Yeah, I didn't do the math.
And this is the shadow. Now, once again, we can use the fact that it's at the same time of day to know that these angles of the sun's hitting these is the same. And Sid is going to be standing at a right angle for measuring his height. And it was measuring at a height where Sid we're going to stand at a right angle. We talked about that before. And we know a flagpole is going to be at a right angle to the ground. You know. Okay? Well, it will. Okay? So we can know these triangles are similar. We know the angle similarity. So Nodalog, how can we set up a proportion here?
48 over 72. 128 over H.
That would work.
48
One second, one second,
equals
buddy.
9,000.
Hey, Nolan. 1 second. 48 over 72 equals 128 over H. That would be an okay setup. That's one of them that works.
It's a great
48 over 72. 48 over 72. They're both talking about Sid. 128 over H. Both talking about the flagpole. Horizontally, 48 and 128. Both the shadows. Horizontally, 72 and H. Both the heights. It lines up. We're good to go. It's one of them that could work. Okay. Both sides. It's a good one. It's a great one. It does the work. Okay. Okay, Charles. Good talk. Okay. So.
You haven't called him cost on your own.
I did actually call him Cost Daddy.
They called me earlier. So, anyway, We could cross multiply to start with, or we can simplify to start with. Either way is fine. What do you guys want to do?
Multiply.
Cross multiply, cool. No dog was 48 times h.
9,216.
48 times h is 9,216. No way.
48 equals 9,216. H equals 190.
No, calm down. Okay. 48 times h is 48h. 72 times 120 is 9,216.
Divide by 48.
So we divide by 48. You are excited.
Let's go.
H ends up being
192.
492.
192. God, dude.
Sorry, I couldn't hear you over your excitement.
I thought I called you Cosbot there.
Oh no, what? So, 192 what?
Inches.
Inches, alright, very good. Questions on that?
Homework.
Okay. We're going to do one of these other two problems and we'll be done.
Don't do that quad.
Yeah.
Right, we'll do both of the problems.
Copy that.
No, absolutely not. Oh my goodness.
I'm gonna die.
Okay, we're going to do number 4 and then we'll be done. Okay. Okay. Find the distance d across the board. This is a really bad
Okay, but
problem. A student identifies points. You know what?
I got it.
Yeah, we're ignoring this one.
Okay.
I don't like this problem at all.
Good.
So, homework?
Yep.
Yes.
Where are we going?
Sal, would you like one?
I don't know yet.
Wait, what is
Oh,
this?
yes, live.
Thank you, my dude. This is where my favorite white letters are. Thank you. What'd you say?
Turn around.
Then you should.
Yeah.
Take a picture, it'll last longer.
Look at go. Let her watch. Let her watch. Oh my god. You can
Why, give me one. Do you like it?
Even though I saw you rolling around earlier.
Ew, Cochina. Are you for real? Oh.
Hey, remember I just said
I said roll it.
I
I
rolled
rolled
it,
it.
no good.
I rolled it. I didn't roll it.
Colton, you have a worksheet.
I was expecting
Bro.
the caramel to be like melted.
Wow.
Guacamole.
This is my last one.
You're lucky.
Or like
Word.
your toast. Mochila.
You're lucky.
It doesn't even work, Brayden.
Look at this. Look at you.
Brayden, it doesn't work.
I never said it worked.
Show me how it works.
Pick your names. Where's Mochila?
Your jersey down here? Mochila is
It's like
Mochila.
I didn't say Mochila, I said Mochila. Mochila.
She's having trouble finding one that will fit you.
It's like
6'7", baby. 6'7" power truck, baby.